Good morning, everybody. Could I just have a quick mic check, please? If you could pop in the chat if you can hear me okay, just so I can be sure. Yes, fantastic. Excellent. Yep, thank you for the feedback there. So good morning or good afternoon, good evening, wherever you are in the world. So my name is Sarah Phillips and I'll be chairing this morning's webinar. Before I hand over to our host, I just want to run through a few details with you all. So the presentation will last approximately 45 minutes and we'll follow that with a 15-minute question and answer session. So if you do have any questions at any point, please do click on the Q&A button at the bottom of your screen to submit them, and I'll do my very best to pose as many as possible of them to Mark. If we can't get through them all in the time, we'll aim to follow up with you after, or of course, you're very welcome to get in touch with Mark directly and he'll share his contact details at the end of the presentation. This webinar is also being recorded and we'll be sending the link to those who registered later in the week, so there's no need for you to take any notes. Today's presenter, as you will know, is Mark Horton, Vice President of Bandweaver Technologies. Mark has more than 30 years experience in security and technology across a variety of markets, including Africa, Europe, MENA, and Asia Pacific. Having initially joined the industry in a technical role, Mark quickly progressed through operational, project management, and consultancy roles to business development, strategy, and sales. Mark was previously Global Sales and Marketing Director for a risk management PLC, where he led the sales team on the implementation of the company's global growth strategy, utilizing a range of fiber optic detection and sensing solutions. Prior to this, Mark was an executive for the global security company G4S, where he was focused on developing the group's regional and global technology strategies. So without further ado, over to you, Mark.
Thank you, Sarah, and thank you for everyone that's joined today. We'll be getting into the webinar now. Sarah's did a great introduction, thank you. So we're going to focus today on FenceSentry and how it is one of the better solutions in the market for perimeter security using optical fiber technology. What we're going to cover over this webinar, a few objectives to focus on. So we're going to focus on this webinar is for shorter range projects. So those typically under 5 kilometers. The last webinar we did towards the end of last year, which is available on the website, we kind of focused on slightly longer perimeters. We're going to focus on shorter ones this time. And they do make up around 90% of the market. We demonstrate the benefits of fiber optic sensing for perimeter intrusion detection systems, or PIDs for short. I'll provide a very brief overview of how optical fiber technology functions. I'll introduce the FenceSentry product and its key market advantages and explain how it's installed and the required components. And then finally, I'll provide a background on Bandweaver, our product range, and just a couple of FenceSentry case studies so you can see where we've used it in the past. Okay, so jumping straight in, a very brief introduction to PIDs, the market. So we've seen over the last 10 or 15 years very steady growth. The PIDs market grows by between 10 and 15% year on year. It's driven by a number of factors. That the rise in the number of perimeter breaches, a lot of money and a lot of investment is spent on hardening buildings, and the perimeter has been left very much as a bit of a weak link in overall mitigation strategies, and that's led to asset and data theft, property damage, business disruption. COVID has made security managers look at how they secure their sites. There was obviously a lot of issues with manpower, with travel restrictions and lockdowns, so there's more increase in technology spend. It's mandated by a lot of governments around the world, certainly around things like utility sites. A couple of examples there up on the screen of bodies that write perimeter security into regulations. The threat of terrorism remains high. The world still remains unstable, and there's some key sectors that tends to affect. We're still building things, so increasing urban infrastructures. We're still building airports, seaports, distribution depots. We're still building things every day. And then really the final one is where users have a desire to improve the probability of detection, and lower nuisance alarms. So that's really technology refreshes, replacing older technology. So when you're designing perimeter security, there's a number of criteria to build in mind when you're designing it. Number one we absolutely agree with, it's retaining operator confidence, so minimizing nuisance alarms, ensuring that they're confident when the alarm goes off, if they do feel it's a real intrusion, and respond accordingly. Early detection. If the alarm triggers when someone's climbing the outside of the fence, there's a much quicker response than relying on volumetric detection inside your perimeter. Being able to integrate with third-party platforms ensures an appropriate response. Sites, when we look at these small sites, they could be unmanned, and they could be 100 kilometers away from a response team, and that needs to be considered for the overall design. And small sites, although we speak about them being under 5 kilometers, well, sites actually start at 10 meters. If you picture a cell tower that now often have a perimeter fence around it, pumping station, block valve stations, transformer substations, and the like, can be very, very small, and need to be appropriately protected. And quite often there'll be some CCTV verification as a requirement. So some of the key challenges: well, fast installation. A lot of the time these systems are installed because there's been a security breach, and to prevent further security breaches. A lot of the sites that we are tasked to secure are operational, so you need a minimum disruption as you're installing these systems. Different perimeter types: chain link, weld mesh, palisade, walls, mixture of walls and fences, barbed wire, these sorts of things. All sites will have gates, both vehicle and pedestrian. How do you protect them, or more importantly, how do you not protect them to allow day-to-day operation of the site? Finding a suitable location for the control equipment, integrating with CCTV or other software or hardware, remembering the reliability, especially if it's an unmanned site, and then ensuring that you have the correct mitigation in place for environmental noise. Every site will have environmental noise depending on its location. It may be adjacent to a very busy road or a railway. It may be exposed to high winds. It's on the coast, or nearby construction activity, or high traffic areas. So there's some of the challenges in securing sites. So if we look now at the technology, and obviously fiber optic technology, and some of the considerations of why to use it. Well, the first is location accuracy. We have the ability to identify an intrusion down to just 1 or 2 meters. It's a very, very accurate system. There's very little infrastructure which is required. There is no power or electrics required in the field. There's no towers, there's no civils, there's none of that requirements for an optical fiber-based system. It's very robust. The cable that we use has a design lifetime of 30 years. There's no moving parts, there's no maintenance required. Early detection, as I said earlier, it means a faster response and less threats and damage to your site. Very versatile. It can be used above ground on fencing and on walls. We even do buried solutions as well. Low maintenance, improved decision making by having using artificial intelligence, which enables us to very much pinpoint the location and provide that information through to the operators. Using our dual channel equipment, we have resistance to cable cut and sabotage. And finally, a lot of what we do is about minimizing nuisance alarms, retaining operator confidence. So these are just some of the aspects of what we use optical fiber for. So we have fence mounted detection, wall mounted detection, a mixture of wall and fence in one. We have covert buried detection, and we have physical attack detection, so protecting vaults, warehouse walls, silos, and the like. So a brief overview of the technology that sits behind our products. People seem to think it's fairly new. But it's not. It's been around for a long time. The principle was first discovered nearly 200 years ago. It's been in commercial use since the 1970s, so 50 years, and has been used in security applications for 20 years, used on more than tens of thousands of sites around the world. It's a tried, tested, and proven technology. And with most technology, economies of scale have driven up functionality, easy use, reliability, while costs have come down. So it's a very cost-effective solution. There's a lot of detail behind the technology, the DAS, distributed acoustic sensing function, but trying to narrow it down to one slide. The easiest way to explain it, and the technology that we use for FenceSentry, is coherent optical time domain reflectometry, or COTDR for short. It's very similar to time of flight principle, or radar, in that the cable is the sensor. There is no separate dedicated sensors required. It has complete coverage along the entire cable length, very simple to install, and it utilizes standard telecoms grade single mode fiber. So here's our site perimeter, here's our controller with the fiber optic cable coming out, and we pulse laser into the sensing cable from the controller, and the light is reflected back. That comes back up into the controller. And we have measurements every 1 meter or so that we pulse several times a second. So on a 5 kilometer site, that's 5,000 separate measurement points. For a 2-channel FenceSentry, that's actually 10,000 separate measurement points that we're pulling multiple times per second. So the light travels down along the fiber, it hits a micro imperfection in the fiber itself, and the light comes backscatter light, which we then analyze, and then we can get an idea of the power and the frequency, because the speed of light is set. We know exactly how long that takes to come back, so we can get a very accurate location. But it does produce lots of data. So the system looks at the data a bit like this. This is how the data is captured and displayed. This is a waterfall. So this is cable length from left to right. And that's about 1 minute of data, with the latest at the top as it rolls down like a waterfall. The brighter the color, the stronger the acoustic signal received. As you see, there's lots of background noise. So we put it through some environmental correction algorithms, which cleans it up and removes any environmental background noise. And it looks a lot cleaner down here. And then we pick up a real intrusion event. This is somebody actually climbing a fence, and you'll see that there's a hand and a foot and a hand and a foot as they climb up over the fence, triggering the system. So that's the waterfall, which is how the data is received. Okay, moving on to FenceSentry itself. It sits pretty firmly in our range of products. So Horizon is what we focused on the last webinar. Up to 50 kilometers per channel. FenceSentry, COTDR products, up to 5 kilometers per channel in 1 or 2 channel formats. And we do actually have an entry-level product called FenceSentry, which is an interferometry-based product. So it's zonal reporting as opposed to location reporting for even smaller sites. So there's a useful chart here that just shows you the difference between our product range. Between interferometry based and COTDR based. So FenceSentry, here's the one in the middle, and we come into some of the detail. This is more of a slide that you can refer back to when you download the webinar later to see the difference between some of our products. So this is a typical FenceSentry installation. This is how it's configured. Here's our site with the optical fiber cables coming back to a central unit where we have a detection unit. So it's FenceSentry detection unit and a FenceSentry processing unit, an industrial PC. And that typically sits on an existing network or a purposefully installed network, and then can connect to other third-party hardware or platforms, cameras, sirens, and then we can communicate via SMS, email, or web browser on your smartphone or tablet. And then we go up to our MaxView server, which is our software, and then up to the control room or the workstation where the operator is viewing the system. That's the typical configuration. I'll go into the component parts in a bit more detail now. So this is the FenceSentry unit. It sits in a 19-inch rack. It's 3U in height. Front and rear of the unit, some little warning indicator lights. And then inside there's a key switch to switch off the laser. Although we use a class 1M laser, which is very unlikely to damage the naked eye. Good practice should be always switch off the laser before you do any work on the system. Any maintenance or any splicing should be switched off and the key removed. And then that's located behind a flap, a lockable flap, so no one can actually. Let me just highlight that for ease. So you see there's a key, there's a lockable flap which stops people accessing the power button. And then around the back, this is a 2-channel unit, so there's 2 optical fiber connectors, and then it integrates with either 485, 232 or RJ45 connections. And then over here, there's a number of voltage-free relays, so you can also integrate at a hardware level. And then for the processor unit, there's not much to see from the front. It's an industrial PC with an on-off button, and then around the back, a number of network connections, and then inputs for keyboards, video, monitors, and the like. So key data. It's the latest generation COTDR, 1 or 2 channels, maximum monitoring range of 5 kilometers. So it can monitor 5 kilometers in a loop utilizing both channels, or you can have a 2-channel version which will monitor up to 10 kilometers in a linear configuration. Vent accuracy down to 1 meter, depending on the fence type. With weld mesh, when people tend to climb them, it does produce a lot of vibration. They do conduct vibration very well in both directions, so it may be 1 or 2 meters. Class 1M laser safety, it's suitable for, let's say, all these different types of fences and walls. 24 onboard relays, 20 are user addressable, 3U rack height, 4U for the processing unit, and we integrate with either our own MaxView software or Modbus software adapter. So when configuring, we provide FenceSentry with its own configuration software, which is called Optical Fiber Security System Configuration Manager, or OFSS-CM. And a couple of the configuration screens you see here on the left. This is what the raw data looks like. So this is, again, the length of the cable coming across and the signal intensity up the side. So you get a good look to see if there's any issues with any splicing or connectors that you've installed. And then on the right, we have the waterfall that we saw earlier, before we've cleaned up the signal and afterwards, and we get very clear intrusion signals after it's been cleared up. And then for the customer graphical user interface, or GUI, we use MaxView. So this is what typically MaxView looks like. It has much of a Windows feel for it. So down here on the left, you have an expandable drop-down equipment list. And then here in the middle is the main screen. So we integrate fully with Google Maps, and you'll see that will be fully integrated. It's dynamic. You can zoom in, you can zoom out, you can scroll around with the perimeter clearly plotted. You can bring in your CCTV cameras, and then you have an event list at the top, number of other tabs where you can access other information. You've got equipment lists, alarms, data, logs, reports, and video. And you can control the cameras directly from this screen as well. It's fully customizable. Some example screenshots of other sites. You can add extra soft buttons and displays for using other third-party equipment as well. Fully customizable for each site that we do. If you don't want to use Google Maps, you can use a schematic. An example site here. So there's 15 zones around this particular site, each supported by a static camera. So you plot them onto MaxView itself. And then you have additional, this is a site configuration here with some additional alarm indications. This particular site had some photoelectric beams. You got some photoelectric beam alarm indicators. If it's been isolated, if the siren's triggered. And then you can have some soft buttons programmed in. So we have some disable the bypass gate or enable the bypass gate, reset alarms. So that's using MaxView, but without Google Maps. That's using a schematic. And one other quick example. This is from another site here. So if there is an alarm activation, what will happen is the relevant zone will change from green to red, and you can have up to 1,000 different zones, and the zone lengths can be as long as you want them to be, from 1 meter to 1,000 meters if you wish. It really just aligns with your cameras, your static camera coverage, or your fully functional presets. So in the event of an alarm activation, it changes to red. There was 2 cameras covering this particular zone, so both of the feeds come up automatically, and you also get an audio indication as well, just to show you that there's been an alarm activation. And as you would expect, there is a full audit of user logins. Operators use a thin client, a web browser, to access the software. So not only does it log who's logged in, but it also logs their IP address, so you know who's logged in and where they've logged in from. And then there's an alarm query page. You can look up and look at events by zone, by severity, by date and time. You could look up any unconfirmed alarms or any uncleared alarms, or whatever. There's a full query page. You can search for any event that you would like to see. So I'm going to show very quickly a very brief video, which gives me a bit of a chance to sip some water. So let me just play this for you now. This gives you an overview of FenceSentry and how it operates with MaxView.
This short demonstration of Bandweaver's FenceSentry perimeter intrusion detection system demonstrates the unique characteristics of this fibre optic based
Apologies there.
technology. In this first example, the FenceSentry system demonstrates its ability to filter out smaller events and to reduce potential nuisance alerts. Here you can see our engineer performs a light tap on the fence. As you can see from the waterfall on the right hand side of the screen, the system clearly can detect the event, but the system is configured to filter out these smaller events and so does not alarm. In the following example, the engineer climbs on the fence. This produces a much larger acoustic signal, which again can be seen on the waterfall. This time, however, you can clearly see the alarm event and the precise location on the map view. For the final demonstration, the engineer performs a ladder lean on the fence, and this time at a different location along the fence. Again, there is a significant amount of acoustic energy which triggers an alarm event. And again, on the map, you can clearly see the precise location of this intrusion event.
Okay, that was just a quick overview. You can download that video from our website as well. Okay, so just moving on with the presentation. Okay, we move on to the practicalities now. So we've covered a bit about the product itself. How does it actually get installed? So just as a typical layout and the components that make up an overall solution, we've spoken about the FenceSentry DU. So this is in a standard 19-inch rack that sits in a secure location, normally an equipment room, server room, and the like, within the site perimeter. So the site perimeter is highlighted here in green. So inside the rack, you'll have your FenceSentry detection unit, FenceSentry processing unit. You would typically have a fiber splice tray where the fiber comes back from. And then you'll have an optional KVM, or this could be your workstation. Don't necessarily need anything in the rack. You'd have a separate monitor, keyboard, video wall, whatever the project requirements are, network switch. And we always recommend a UPS to prevent against power outages or spikes or surges. So that's the equipment which is typically installed in a rack. And we do actually provide all of this equipment, if you so wish, but most people tend to source the rack and the UPS themselves locally. And then from the rack out to the perimeter, we use our fence line optical fiber cable. So it's one cable with multiple cores. And we call this the lead-in cable. So it's non-sensitive, it's programmed as non-sensitive in the software. And it comes out typically to a pit with a joint box, and then the cable will run all the way around the perimeter and back to the joint box. And I say it's one cable, but multiple cores. 2 cores is what we typically use. And the reason we use 2 cores, so here we are, here's the rack here coming out to the junction box. And we have 1 core, which is effectively monitoring in a clockwise direction, and 1 core monitoring in an anti-clockwise direction. Again, just one cable, but with two cores. And the reason being is if someone cuts the cable cutting through both cores, the system still monitors up to the point of cut. So this core is still monitoring up to the point of cut in this direction, and this core in this direction. So you pretty much retain 100% detection. So a cut, somebody cutting the cable, firstly, it causes an alarm condition showing the exact location of the cut, so it doesn't defeat the system. And you can repair the cable. There's no need to rerun it. It can be respliced. In a couple of hours, you're back up and running. So this is our cut immune configuration. And we use a cable we designed and manufactured ourselves called FenceLine. It's a single mode telecoms grade cable. Again, it's no maintenance required, totally passive, no movement parts, not susceptible to corrosion. It's UV resistant for outside use, and has a design lifetime of 30 years. It's immune to EMI, RFI, and any sort of interference. And there is no in-field power or communication requirements. It's very lightweight, flexible, easy to install, but designed to have that 30-year lifespan. Okay, so how do we actually install it? Well, for fence-mounted installations, it's typically cable tied using UV-resistant zip ties or metal ties. About every 30 or 40 centimeters, about 3 ties per meter, or every 4 to 5 diamonds for a chain link fence. And it's typically for most fence types, weld mesh or chain link, it typically gets mounted about halfway for a fence heights up to about 3.5 meters, including fence toppers. And that will provide adequate detection of those fence heights. If they're higher fences, you can have a different pattern, and we can advise on the design of those. So just a couple of examples. So you'll see here, this is a weld mesh, and there's cable ties about every 30 centimeters, the cable's in the middle, and you come to the gate, and then you come off of the gate, off the fence, towards the gate post, and we loop around and back down, and then we come underneath and back up the other side and around this side. And that ensures that no one can climb the fence or cut through the fence, the gates themselves, as well as the fence. So that provides security for the gates as well. For palisade fences, as an example, typically the cable would come along across that top rail there, and that would detect someone climbing over the fence, cutting through the pales or trying to remove these pales as well would detect it. For high security sites, where there's a risk of digging under or tunneling under, depending on the foundations, you would typically take a cable across the top rail and the bottom rail, providing additional level of security. And when we come on to gates, well, there's 2 ways. For gates that you wish to monitor, this is the typical example you saw in the previous image. You come along the fence or the wall and you loop on. This type of gate is a metal faced gate, so they're only climbing over the top of it. So you would detect it here, and then you come down through typically a galvanized tube underground, back up the other side, and then you continue along the fence or wall. A couple of examples there. So that will detect somebody climbing over the gate. If you want to have them unmonitored, you would simply come along, down, across, and back up, and that could be for where the gate is actually open for day-to-day usage, or where it's protected by a different technology, where you have an infrared beam or a LiDAR or microwave or something else that you may want as your overall site mitigation planning. So you can either monitor it or have it unmonitored, depending on your requirements. So I think it's good just to recap on some of these advantages before we move on. So fiber optic for FenceSentry, high probability of detection. We talk about 95% plus. Very, very low nuisance alarms. Our advanced AI, it mitigates against background noise. Very accurate for location reporting, early detection, improved decision making. We provide cut redundancy using our 2 channels. It's very important. It's intrinsically safe for oil and gas sites or sites where there's a risk of fire or explosion. Minimal maintenance requirements, 30-year lifespan, very fast installation to get up and running in minimal time, no power electrics, and unlike most other technologies, unimpacted by terrain, line of sight, movement inside the perimeter. You imagine a busy distribution yard where they store goods outside, and they don't want people coming over their fence line and stealing things, but they can't have volumetric detection because there's people moving around all the time. Fiber optic system is perfect for that. It's resistant to weather, environmental conditions. And from a financial point of view, it has a lower total cost of ownership when compared to other technologies, and very much reduced infrastructure costs, civils, electrics, towers, foundations, these sorts of things. There's none of those requirements. So it has a number of very significant cost advantages. So we talked about FenceSentry as a standalone. Well, typically they will always be integrated to something else. So some of our partners use MaxView as a standalone system with cameras plugged into it. But more often than not, we're asked to provide our PID systems as part of a wider risk mitigation plan that has multi-layered approach. So there is a need to integrate into subsystems, CCTV, access control, screening, scanning, to provide a joined up approach. So all of our systems can integrate fully with a variety of third-party platforms. So PSIM, VMS, SMS, SCADA, DVR, NVR, whatever is required. So we can output precise information of any alarm event, unique ID, exact date and time of the event, the location of the event, typically to 1 or 2 meters. When we're using Google Maps, we can provide the GPS coordinates as well. Good if you're using drones, as an example. We can trigger the preset of the closest camera to provide operators a visual verification of the event. And it's important that we can detect simultaneous multiple perimeter breaches. And kind of this is how it looks. We have our MaxView software sat in the middle here. We use a SQL Server database, and users come in via web browsers, and we then integrate to PSIM, VMS, but we can also bring in CCTV, other third party, and output things to sirens and other things. Multiple DAS systems can be connected, so multiple FenceSentries or Horizons or Zone Sentries. And then we communicate via email, SMS, or web browsers on smartphones. Connect to SCADA and third-party sensors as well. So just a couple of real installation examples. So we got a residential, oil and gas, and high-tech data center. So the first one, residential complex, is down in Brazil. This is a picture of the site. It has about a 6-kilometer perimeter. There were some cameras located at key integration. It's a residential site. They wanted a discrete installation. They wanted a kind of a remote doorman concept. A little bit unusual, in fact, that there's differing perimeter constructions, and you'll see at the top of it they have an electric fence to deter people from entering the property. So we installed our cable onto the electric fence, one of the strands, both on the fence and on the walls. It varied around the site, and then as we're configuring to ensure there's intelligent tuning of the algorithms, one of the drawbacks of this sort of stranded cable, birds love to come and sit on it. You get 10 or 20 birds sat on it, so we ensure that everything's set up so wildlife do not trigger the system, but somebody climbing over would. And then for the oil and gas, this is a major oil operator that had 33 sites, different facilities, compressor stations, maintenance and management offices, pump stations. And it was a combination of new sites and upgrades to existing facilities. So a lot of these sites were in operation as we're installing them. Typical example of what a compressor site looked like: couple of kilometer perimeter, couple of gates, both pedestrian and vehicle. A couple of images from the site, so you'll see it very similar to the schematic that I showed you earlier. Typical rack, network switch, FenceSentry PU, FenceSentry detection unit, the DVR, all the camera feeds coming in, and a UPS somewhere near the bottom. And in the control room, a fairly large video wall with Google Maps. We even do 3D modeling if you so wish, and then camera feeds coming in as well, connected to some beam detectors. There was some access control also as part of this site. Again, some different perimeter and fence configurations. Some had a fence on top of a wall, some had some barbed wire strands on top of the wall that we protected. And a quick example of the gates you'll see here, we've come along the gates, and all these sites were protected by beam detection. So we stop the cable detection here, we come down, we come under the road, come up, and we start again here. And an idea of what the configuration looked like was on each site there was an equipment room that had our FenceSentry units in, and a DVR and a network switch, so we're protecting the fence, and the gate with beam detectors. And there's other things, turnstiles, access control. There's a lot on this system, and all monitored from their main control room remotely on a single software platform, so they can see everything going on simultaneous in real time. And the final example we have for you is a data center in Singapore. There was a requirement for cable cut redundancy and integrate 24 cameras and beam detectors. So this actually used a schematic and not used Google Maps, with a number of zones set up. And again, like a lot of the sites we protect, has varying fence and wall types around the perimeter. So just a couple of quick examples. So finally, for those that don't know Bandweaver, so a very brief overview of who we are. All we do is optical fiber solutions. We use them in a number of different sectors. Power sector, so we monitor above and below power lines for intrusion, for cable theft, but for also issues in the network power transmission. Fire systems, we have a linear heat detection that we use in tunnels, indoor buildings, these sorts of conveyor belts, these sorts of applications. Security, so perimeter intrusion, what we're talking about today, we also use for protecting borders. Pipeline solutions, we monitor above and below ground pipelines for third-party interference, for theft, for leakage, these sorts of things. And smart monitoring, so we monitor a wide range of assets, conveyor belts, railroads, smart cities, for preventative maintenance planning mostly, but also for some reactive usage as well. We're actually just celebrating our 20th year of operation, more than 5,000 systems installed, 40,000 kilometers of optical fiber, and we employ more than 300 people with two key sensing technologies: distributed acoustic sensing, which I've been talking about today. We also have distributed temperature sensing, and there's a number of other webinars available on our website where we talk about our DTS solutions as well. Truly global business. Over here in the US, we have a sales office and some manufacturing facilities. In Canada, we do some R&D. Our international offices are based in the UK, just outside of London, where we have our sales operations, technical support, and logistics teams. We typically have a sales office in Dubai, but with the pandemic, that's been closed down for now. But I'm sure we'll be soon opening that back up. And then over in China, in Shanghai, we have a manufacturing plant, our Asian sales team, and some more R&D staff. Unlike most of our competitors, we actually build everything ourselves from a component level upwards in our own 10,000 meter square high volume facility with a class 100 clean room. It gives us total control of quality and a guarantee of supply. During the whole pandemic, our manufacturing process was uninterrupted. We have rapid product development, so we can customize our solutions for specific projects. And we have an emphasis on continual cost reduction with the most efficient supply chain in the world. So reliability is a huge focus for us, with expertise in telecoms based high volume product design and manufacture, and then bringing in our machine learning, AI, DNN, RNN, to have some really market leading products using artificial intelligence. International standards, we've invested very heavily in third-party accreditation. These are just some of the standards we adhere to, and some of the bodies that we work with in terms of implementing and getting certified. Reliability is at the heart of everything we do, and absolutely a top priority. That's something we continually strive to improve on. We have products, you see, 30-year MTBF and SIL 3 rated. Okay, so our last two slides, and then we go to the question and answer session. I'm almost running on time. So just very briefly, why choose FenceSentry? Provides complete coverage at all points along the asset, significantly whole life costs when compared to alternative technologies and competition, reduced infrastructure costs, very robust, low maintenance, resilient to cable cut and sabotage, and then information benefits, very accurate location, early detection, improved decision making, so the operators can make an appropriate response with a high probability of detection with low nuisance alarms, retaining operator confidence. And then finally, why choose Bandweaver? Well, some of the benefits of dealing with us: 20 years experience, 5,000 sites trusted around the world, component upwards manufacturing process, ensuring we retain full control of quality management and reliability. Large R&D team. Spoke earlier about customizing some of our solutions for projects, and we're doing that. That's a weekly occurrence for us, where we make some changes, mostly to our software, but we can do it from a hardware level as well, where the end user has some very demanding requirements, and we have the ability to be very agile and respond to those client needs. I think it's very important to have a family of products, and for PIDs, you'd have seen the ZoneSentry, the FenceSentry, and the Horizon. Ensures that there is a product for any size application. All of our hardware and software solutions can integrate with a wide range of third-party platforms. It's a very connected world these days, and our clients expect that. And finally, Horizon, absolutely market leading. The first company and the only company to get a buried and fence mounted detection on a single cable, so it can go underground, up onto fences, down onto walls, all from a single cable. Absolutely market leading. That's on our Horizon product. So hopefully that covered all the parts in terms of the objectives of the webinar. Took you through the technology behind how it works, but obviously in a very high level. I'm not a photonics engineer, and it is very detailed technology, but very reliable, been around a lot, been used a lot. The principle is actually very straightforward. FenceSentry, some of its advantages in the marketplace. So I think now we could go on and take some questions.
Brilliant. Thank you very much, Mark, for that fantastic webinar. So quite a few questions come in through on the chat and the Q&A. So I'll start with hopefully an easy one. Where can we find more information about the product? Okay, I always like to get started with easy questions. So you see up on the screen here, bandweaver.com. It's our website. There's a page designated for FenceSentry. You can go on there. And on there you'll find the video that I showed you earlier. There's a data sheet and a brochure that you can access all the facts and figures. And there's also information there about MaxView. There's some application notes you'll find on the website as well. A bit more information about how to install it, and some of the considerations and some of the challenges. Yeah, so there's a full range of information up there on the website. For any questions that I haven't covered and we won't answer now in the limited time we have left, my email is up there as well, and please just drop me a line. Thank you. Can you explain exactly what you provide as part of the FenceSentry kit and what other ancillary equipment is necessary? Okay, yeah, so we describe it as selling as a kit. So when you purchase FenceSentry in either the single or the 2-channel variant, you get the detection unit, you get the processing unit, you get the configuration software, OFSSSCM, and you get MaxView for Fence, and that's the kit. You then also buy the Fence line cable, and you calculate
the exact distance that you require, and we can have it cut to length to ship for you. And there's a few ancillary items you need, so we can supply them if you so wish. Most people tend to source them locally themselves. You would need a rack to put the equipment in, a patch panel is typically required, and a splice tray and a UPS. And then the typical requirements, they will vary from site to site and requirements of the end user, but they're the key critical items.
And on a related note, can you use FenceSentry without MaxView?
Yes, you can do. A lot of our customers use it as a standalone product, and that's how a lot of it is utilized. They'll have a few cameras which plug directly into a third party, and we can connect via our Modbus adapter or relays. And a lot of our customers are happy just to use relays trigger. The relays are programmable, so you could set FenceSentry up, maybe have it as 10 zones, and then you assign a relay to each of those 10 zones, and then it's a straightforward hardware interconnection.
Okay. Several times you've referenced the total cost of ownership. How is that calculated? Yeah,
apologies. It's always hard to know how much detail to go in during these limited time webinars. So total cost of ownership, it's something that we have a lot of conversation with end users, and it normally comes from it's more often part of tenders these days, when we're asked to provide information on the total cost of ownership over a 10-year period. And typically that's calculated by taking the initial equipment cost, the cost of installation, and that should include everything. So that's all your civil works, your electrical works, your communication works, your towers, your excavation work, your foundations, and everything, and that's included. Then you look at your 10-year lifespan, and then the maintenance costs for that 10 years with the Bandweaver FenceSentry system. They're the minimal to no costs. The sensor cable needs no maintenance. Controllers are fan free. There's really nothing to maintain as part of the system. But you compare that to other technologies, perhaps a camera system. Maybe you're going out every 3 months to clean the cameras off, and then you have to include all the costs of getting up to the cameras, or whether it's cherry pickers, scissor lifts, bladders, and things over the course of that 10 years. Annual maintenance contracts, but also how many times that equipment will be replaced over the course of 10 years with the Bandweaver FenceSentry. 30-year lifespan of the cable. I would expect not to replace the controller in 10 years. 10 years is a good lifetime for a controller, but with a CCTV or radar, how many times you have to replace those cameras to keep them working, replacing bearings, motors, and those sorts of things. So you add all those numbers together, and then you'll compare those two numbers for total cost of ownership over 10 years, and you'll see there's a fairly significant difference. And as companies are a bit more careful on spend, on security spend, they're looking in more detail in the total cost of ownership.
Okay. Could you confirm the maximum length of perimeter that can be monitored?
Yeah, and I think it's important to mention that I think I covered it with the two types of wiring configuration. There's wired in a loop, in which case the channel range of 5 kilometers is your maximum distance that you can monitor, and that does include your lead-in cable. So if your equipment is 0.5 kilometer away from your fence line, that reduces your monitoring of the fence line to 4.5 kilometers. It's a total distance of 5 kilometers. But if you wire it in a non-cut immune configuration, i.e. you take your 5 kilometer channel in one direction and 5 kilometer channel in the other direction, you can monitor 10 kilometers in a linear configuration, but that's not a cut immune configuration. So in a cut immune, it's 5 kilometers total maximum distance. In a linear configuration, it's 10 kilometers, but that does include the lead-in cable, which is important to remember.
Thank you. A question from Paul. How long does it take to commission a system roughly, especially when accounting for wildlife and other environmental disturbances?
Yeah, it's a good question. Most of the detectors are pre-configured when we ship the unit. So it will depend. The answer to the question is depend on how much environmental noise is going on in the background. Typically, it's a day to configure it. Once it's installed, it's a case of walking around, doing some example typical fence climbs of the fence, ensure it gets detected. There can be a period of monitoring just to make sure that there is no events that occur that they're not there and not present when the system being configured. So for an example, if the system's set up on a Monday, but on a Thursday, there's a huge goods train goes past on a Thursday, and there could be a quick revisit just to change the configuration if that has a potential of causing problems. With all our systems, you can connect remotely. Our partners, the installers, can connect remotely, or we can connect remotely to help on that configuration. And typically for most of our new partners, the first few projects we'll assist either on site on the configuration, or remotely we'll dial in and connect and help and set up. But from a smaller site, the configuration and commissioning and training is generally done in about a day.
Thank you. So quite a few questions around VMS and camera compatibility. So which systems would be compatible, and how would that be done?
I guess the easy answer is we can connect to anything. We've connected and have live systems up and running with all of the major VMSs, PSIMs, SMS. I'm always nervous about listing 10, because if someone sees there's the name not on the list, they'll assume that we can't connect to it. We can. We have a very open platform for integration, and as part of the product sale where there's third-party integration, if we don't do it already, then we'll write it. It's very simple to write an additional API to work to a company that we haven't done so in the past, although we've connected and worked it very successfully with all the leading companies to date.
Okay, also a few questions around the route to market. So, and also, do we use subcontractors to install the equipment?
Okay, so there's a couple of routes we have to market and it depends on whereabouts in the world you're located. In certain markets, we have appointed distributors, and you buy remotely from our partners, who can provide local technical support and expertise, or you can buy directly from us. But it's important, as a manufacturer, we don't install anything. That's on our partners to install. We do provide support, so we can send our engineers to site and support on the commissioning, but we don't actually install anything. We're there to provide guidance and training. So you would need the ability to install it. I mean, installing the cable and defense is very, very simple. Whole bunch of cable ties, and installing the equipment. You could consider the equipment as the same as installing a server or industrial PC. The ability to slot it into a rack and to power it up, and to make optical fiber splices, fusion splices. And if you don't have that ability in-house, it's quite easy to get a telecoms company to come in and do splices for you. These days, it's fairly simple and fairly low cost.
Okay. Also, do you have many customers in transport, so airfields and airports?
Yeah, actually, it's certainly one of our growing markets, where we have a lot of inquiries from the aviation industry. Post 9/11, a lot of focus was on securing airports, and one of the issues has been perhaps over the last 10 years, a lot of investment has been made in securing the terminals, but not much investment has been securing the perimeters. It was absolutely the weakest link, which will always be exploited. Yes, our systems can detect perimeter breaches, but also ignore the jet planes. And it's always an issue when you have jet planes whipping by the fence line. The system can be very simply programmed to ignore those, but still detect an intrusion as well. Yeah, so very, very suited for the aviation industry.
Okay. For small sites without a building, where does the equipment go?
Yeah, and that's actually it's a good question. We talk about some of my configuration, big rack somewhere in a nice warm equipment room or a server room. A lot of sites, pumping stations for oil and gas, or valve stations for the utilities industry, substations. They simply isn't a suitable building, and in which case our customers tend to just buy an IP68 cabinet, very similar perhaps to people that are installing cable TV in your local area. The big green cabinets you'd have seen, they're very vandal resistant, theft proof. The FenceSentry has an operating range from 0 degrees to 45 degrees, I believe. So that's a wide operating range, and if you think the temperatures will be outside of those, either a very small heater or an air conditioning unit added to it will ensure it keeps within its temperature controls. And that's quite common. We have a lot of people sourcing those IP68 cabinets, and they tend to get just mounted onto a concrete plinth and bolted down, so no one steals them.
Okay, so when an alarm event is reported, what is the process for reporting that? Will it provide XY coordinates so a camera or even a drone can respond?
Yes. So we have a number of our customers have integrated fully into drone systems, so that when it's using Google Maps as the user interface, the system will provide the GPS coordinates, so that for a drone example can fly. And it's great for remote sites where the cost of putting cameras all the way around a perimeter is prohibitive. Having a drone that will fly out instantly to the exact location is hugely beneficial. And also you can send out a text message or an email to your mobile guard, your patrol force, that will provide the GPS locations as well, so that they can immediately go to the area of intrusion, speeding up that response time, which is pretty key.
Okay, thank you. Only got time for a couple more, so apologies if I do miss yours. We will come back to them separately. So quite a few people asking about FenceSentry. How does it fit into the portfolio? How can we find out more information? Okay,
so the next webinar I do will be on FenceSentry, and that will probably be in April or May, depending on how quickly I write the webinar. And we'll announce that on our usual social media, on LinkedIn, Twitter, up on the website. If you registered for our mailing list, you'll get an email about that. It's a product which is really exciting. There's a lot of interest for it at the moment. It's an interferometry based. I don't want to give too much away here because I want people to join the webinar, but it's an interferometry based product, low cost, aimed at the entry level of the market, either 4 or 8 zone configuration. Very small, very easy to wall mount if you wish to. Does integrate fully with MaxView if you so wish. Perfect for wellheads, pumping stations, lots of very small sites, cell towers. It goes a lot to solar farms. We protected a lot of solar farms with it as well. So yeah, so just watch the space, and we'll be announcing a webinar very shortly.
Fantastic. Thank you very much. Unfortunately, that's all we have time for. So if your question hasn't been answered, you can see Mark's details on the screen. So do feel free to contact him directly. You'll also be receiving an email over the next few days with the link to the webinar, so you can watch it again in your own time, and then pick up on any of the details that you may have missed during the presentation. So Mark, did you have any final remarks before we sign off?
No, I'd just like to thank everyone for joining. Apologies we didn't get to everyone's question. And as Sarah said, that my email's up on the page. Feel free to drop me a note. I'm happy to answer any questions, or I'll have a look through the list of questions that people asked. If I may just drop you a mail just to answer them. And again, thank you everyone for joining.